All right, welcome back to another episode of P5Live Sessions. I just realized I should probably work on another intro because this sketch tends to get the fan blasting, trying to handle all those points. So we have a nice fan noisy background to kick off each session, but maybe that's reasonable when we're coding in the browser, doing all kinds of heavy lifting. Yeah, so thanks for joining now live or in the future. What we're going to do today is hang out one more day in the domain of waves, because that's kind of a fun little side project obsession since a couple weeks, working on this oscillation sandbox, which has some fun features coming to it very soon. Maybe at the end I'll show a little sneak peek of the next step of sonifying these things. Soon the website will make sound. But what we're going to do first is I'm interested to mess around with a bunch of these things in P5Live, this time without audio. It is super fun to VJ, but sometimes it's nice just to mess around and you can listen to your own music. And what I'm going to do specifically is try to mess around with the collection of all of these things, like all at once in a sketch, so that I can just randomly pick one of the algorithms instead of swapping back and forth, copy pasting, and then maybe see what it's like in 3D with a bunch of them or attaching them to each other for XYZ. We'll see. But something that was done on purpose was that these are all sitting in a JSON file. So you can easily go and grab that file. It's sort of, the collection is this JSON, so it's possible to use in other domains, other projects, who knows what. And what I'm going to do is copy this collection, and I'm going to go back to P5Live and import it so that we can extract information from it. So I'm just going to call something data, and maybe I'll make another thing called algos. And I'll make a function that is a preload to load this thing in. So hopefully this is grabbing it, and I'm going to quickly test out if this is working by just saying print data. And run the code. I don't know. We have an error. What is the problem? Oh no, we're running into some core. Oh no, but we did get an object. What's going on? We are getting a cores issue. Why are we getting a cores issue? Bummer, I did a super quick test just to see that I remembered how to load stuff. And now, of course, it's not working. Let's try this one more time. Okay, the URL was slightly different. Just clicking copy paste versus actually grabbing the URL. Okay, I could tell something got loaded, an object with a collection. There's all the data that sits behind that website. So what I'm going to do is, this probably isn't necessary, but I'm going to say algos equals data dot collection, because that's this guy here. That's actually the array of all of these things. And sometimes in P5, it can be kind of weird to load an array of data. So now I just quickly test that it's working and say algos. And there's the collection, 37 things. Cool. Yeah, so each one of these has an algo, a shape, just a name for it, a wave, and a handle, who came up with that algorithm, or who added it to the collection. But algo is the most important of these things. I'm going to hide the console. Somehow this little thing doesn't want to go away. Go away. There we go. Yeah, so let me start messing around with one of these. Maybe I'll cheat and just grab this little snippet from the website suggesting for making a normal wave. Let's have a background just in case we want it. Clean it up once. And this is where I need to put my algo. So what I could technically do is say, this should work, to say eval algos 0 dot algo. There we go. We have a little bouncing ball. And now I can turn off the background. And yeah, that's great. So we can already start to just grab a random one of these things. So that was number, whoops, let me grab number 2, technically. 0 is the new 1. I'll fade out our image. And then if I go to number 3, it has this kind of like sharp point, which I can quickly tell by going to the page, and now we're on this one. So if I want to get to the square one, that is the 5th one in, which would be the 4th array. And there we go. It looks a little bit different when it is dots instead of a line. It's going up and down, but it's like a square wave. Yeah, so here I'm doing like this, whatever was calculated, which is normalized, times the whole height, but I could say half the height, and then we get this more reduced line. Okay, so that's interesting that I can just spontaneously grab one of these things. Number 8, what was this guy again? I was doing this nice kind of, oh yeah, this was the heart shape one, I believe. And something that was also fun to do at times was to like make it a closed form on itself. So maybe I'll duplicate this and have 2 of these things. One is doing its thing in the background, and one of them is going to be that value just with a cosine. Let me call it let x cos be cosine of x. I think I have to go like times, I don't know, maybe times half the height. Let's see what this looks like. And I think I have to say width divided by 2 plus that. And it's going way too fast. Maybe it's supposed to be x pause. Nope. Interesting. Maybe just this times 0.1 or even, there we go. All right, there is the heart shape. You can tell, but it's a little squished. So this should actually be maybe just like times 1/4 of the width. There we go. Yeah, and that's interesting. So one of these is now a closed-in form. It's not going down far enough. So I would actually make this thing maybe go divided by 3. No, the opposite, times 0.75. There we go. Oh, it was just Valentine's Day the other day. It's a heart. But maybe it's good to make a variable. Whoops. So I can quickly jump to any of these. I'm going to say like algo cell equals, let's check out number 6 and throw that in there so that I could change my mind at different times. And then maybe I'll say algo 6 actually equals 8. Go back where we were. There we are. Or I say it's number 12. What's that thing looking like? Maybe they should have different colors so we can tell them apart. Maybe this one will be a stroke that's white and a fill that's black, and do the opposite for the other one. There we go. So one is wandering. Oh yeah, this was this interesting like C-section, I called it. This just circle cut in half. Or number 13. Interesting. Yeah, this was this one that was kind of like ladders going down. That was, where are we? This one. These steps. It's maybe not going fast enough across to make those steps appear. Or it is. It just looks so different because they are not attached as a line. Maybe if this went faster. Actually, I take it back, slower. Okay, interesting. Yeah, but let me start to build a bunch of these things and see what happens, because it might be fun just to see like, actually 2 things. I'm going to try mapping one against another one, and then maybe to make a small grid of these things and then see what we can do with a bunch of them. So we have our X going. I could have multiple of these Ys for like 2 different things. Let's see. Let me actually start labeling these things so I can keep track of it later. What is this? We'll call it like wave, waves, whatever. And let me grab, I think I'll start with the closed form. And it was interesting actually to start with maybe a super simple form. So this is wave number 0, and wave number 1 looked similar. It was the infinity symbol. No, it wasn't, not quite. Just trying to think of what would be an interesting one to combine with it. It's kind of interesting. I don't know. We'll just have to try it. Okay, but I'll start out with a super simple one that was just making a circle. That is this one here, just a basic sine wave, so that we can really tell what happened, that something changed. So this is the y that it is based on, and its x is simply just being like a cosine moving at a certain speed at 0.1. But if I made this actually another one of those waves, what happens if I do that? If I said x cos is actually the same thing, eval one of these things, algos, let's say algo cell plus 5 dot algo from that data set. And then I need to multiply it by a number with divided by 4 because it's normalized. Yeah, so number 4 was, who knows what number 4 was? Or rather number 6, I guess. Let me just pick a random one. Like number 8 we know is the heart. Okay, so it almost looks like we're getting a part of the heart. It's number 9 like, and we're also doing, no, we're not doing cosine anything. It's just evaluating it. If I want to be really correct, I could multiply it by the same value. So I could just, let's see, this is saying times 0.75 of the height, and maybe I go with times 0.75 to really stretch the thing out. Let's try another one. Yeah, I have a feeling these are ones that are kind of like rectangular waves. Number 12. Yeah, I really don't need this cosine. That was interesting at the beginning. Maybe I clone it once before I trash that. So now I'll get rid of what we're not actually using because I'm overriding it. Try another one, and then it might be interesting just to build a bunch of these things. They're just kind of randomly mix and matching from the collection. 15. Yes, these are all still based on this x pause, which if I change it, its speed, okay, just simply we'll move them both faster. Smoother. Let's check out another one. And actually, what I should probably do is change this one, this algo cell, because that's just the plain old spinning sine. So if I change that to some other one, let's put it maybe back on what was the heart. Then I'll mix and match with yet another one. That's interesting. All right, that one was freaking out, whatever 19 was. It could also be nice to know which one I am looking at, what it was called. Maybe it's interesting to put little thumbnails behind each one, but technically I could go grab the name. I could print out, who are you? Let me say print that dot wave. This is upside down noise, or I could say dot shape scatter. Okay, that makes sense. Up, down, scatter. It's kind of chaotic. 21. Ooh, it has a nice bouncing structure. That's quite cool. Boing. 22. That's quite nice. Has a really cool sort of bouncing quality to it. Let's check out what was that one. That was spiral. And what about its wave? Was ramp with period height. Ah, okay. Yeah, that's this one here. It's just doing like this saw wave. And I should jump way further into the collection and see what some of these other crazier ones look like. That was one based on tan. Ooh, that's nice. I think that's that one that's kind of like using log that slowly faded out. What was this guy? 30. Bald patch. Ah, yeah, that was this one here. It was a weird name. It kind of looked like grass with a little bald patch. What about its? Yep. Turn that off. What about 31? Okay, that's kind of interesting. It does this like bounce and freak out, bounce and freak out. Let's start adding another axis to these. This is fuzzy peak sign. Ooh, that's quite a nice one. Okay, actually, I'm going to use that one. Number 32 was ramp sign, and its shape was technically scatter. Okay. Yeah, so I'm going to do two things. I'm going to quickly clone this one more time and say this one rename is actually about doing 3D, because then I might come back to this early one before it was 3D and turn it into some kind of a class. But I'm going to go WebGL time, WebGL, all the coordinates screw up until I just get rid of this centering. There we go. And there is no opacity in WebGL, so I can just trace the thing out. And then I'm going to add a third axis to this thing. So right now these things are all being placed in there directly. And what might be interesting to do is actually have like a circular buffer so that I'm actually keeping all those positions there, because if I try and do some rotation, like rotate Y, radians, frame count, is going to get really messy because it's just overriding. So it's nicer to have a background on, and there we can see we're kind of spinning around it, but it's not leaving the trace. So it's probably worth setting up a buffer to actually keep track of all those positions. But first, let's get another axis happening. Or vice versa. Maybe first try and make the buffer so that we can actually see the form that it's generating. So let's try and create that. Let's call it let C equal just some random array. And instead of drawing directly where we want it, let's actually translate these. Translate to that spot. I'm going to scroll that up. And then what I'm going to do is I'm going to keep pushing values. Like every frame, I'm going to push this value. C.push, create a vector of that position. And then what I need to do is trash them if they get too big. So if C.length is ever bigger than, I have no idea how many I need, but maybe like 100. If it gets too big, c.splice01. I'm pretty sure that's the short way of just trashing one of those things. And now I'll loop through all the stuff and say for let I be 0, I is less than c.length. C++. Where am I getting C from? I want I. Then I want to do a push, a pop, and in the middle of it, draw my things. Let's see if this works. And now I'll turn on a background. And we are not getting all the things because I need to actually use those values. So I need to go and grab it. So I'm going to say let c temp equal ci. And then c temp.x. Maybe I didn't want to do that. Yeah, I did. C temp.x and c temp.y. There we go. Yeah, so now it's actually storing all those positions. And 100 of them, that might be enough, that might be not enough. Maybe we need 200 of those positions. I'm sure there's a clever number to figure out how many we need. But the cool thing is that now that I'm actually storing them, I can rotate in 3-dimensional space and see those things, but they are super flat, which is not so cool. So now we need to play with the z-axis. What could also be nice to test out is instead of using an ellipse, use a low detailed sphere. Let me go sphere detail 5, so it's not too... No, that's not what you do. I'm thinking of something else. Bring back the ellipse. I'm going to say a box that is like... not a box, although a box is kind of cool. I wanted to have a sphere that was like 50, and then you say the number of vertices that it uses. So these things are not spread out enough, but it could just be we need smaller spheres. And it might be nice to say that the fill is actually white and that we have lights. And no fill, no stroke. No stroke. See how long it takes for my fan to kick on. Maybe even lower detail. 3, we could have little hexagon-y looking things. Okay, but we definitely need to get a z-axis in there. So I'm going to temporarily turn off the 3D, turn off the lights, go back to how we had it. What happened to our stuff? No stroke. There we go. We need a stroke. So now I'm going to try and get one more algo in there and use it for the z-axis. Maybe I should give these things a little bit better names. I just called this let y. This is x cause. I'm going to quickly clean up the names. I'm going to turn off live coding, Control A, so I can say y. Actually, I'm going to call it axis y. And then I have to go find where it is. I think it's just here. And then I'm going to call this axis x. And I'm going to put that there. And then I'm going to invent an axis z. Before I do, I'm going to make sure this works. Good, we're still working. So I'll turn on live coding again. Axis z will be some other random one. Let me go grab like number 12. And then here I was doing times 7.5 right up there. It doesn't really matter if I do it up there or down here. I guess I could make this cleaner by doing this also up here. So it's just the y-axis. And then let's add axis z and see what happens. Recompile. Nothing yet because I also have to translate that value. That's why. C temp.z. Ooh, there we go. Yeah, so now it's probably spinning too fast. We should slow it down. Divide this thing by 2. Yeah, so then it's a question of what are the right numbers to use. So maybe instead of just this being like a single value, it should either be a create vertex or it should just be an array with a few values. It probably makes sense that it's a create vertex actually. So I'm going to override this thing. I'm going to turn off live coding for a sec. And I'm going to say in the setup that algo cell equals a create vector, and we're using number 8. Doesn't really matter. 32 and 12. And then down in here, I'm going to say this is actually algocell.x. Oh, rather that was y. It doesn't matter. Let's see what happens. .y. Whoops. .z. Recompile. It's not happy. Algocell. Algos create vector. What is the problem? Algos. This thing killed it. There we go. Okay. Trash that. Yeah, so now the interesting thing is just being able to randomly create different ones and test them out. So actually what I should do is I should just say, let's generate a bunch of random numbers. So I'll say random algos. I could actually grab this could actually be, instead of this being a vector, I changed my mind. This should be an array. This should be an array holding a bunch of things, and it's going to be a random algo, and actually grab that item that's there. And now I can remove all of this and just say use algo x, use algo y, use algo z. Okay, that should work. Random. Did not work. Val random algos. Quickly check. Can't grab the algo of undefined. Print algo cell. Clear. So we have the 3 algos. Because it's not XYZ anymore. It's simply the first one, the second one, the third one. Okay, there we go. Yeah, so the advantage of this is now I can just make this thing be a little function to call every once in a while. I'll name it down here and call it function rando waves. And all that will do is it will just set algocell to be some random waves. So I will turn off that print and I'll call it once up here. So every time I refresh the sketch, it'll be a random selection of those. Ooh, that's nice with that tan in there. Instead of having to totally start it over, I can also set up some kind of key. Maybe I use a space bar or something. If key equals space, do my rando waves. Yeah, so then I press space and it doesn't have to do a hard reset. It just is gonna, we're storing 200 of these things. Maybe I store fewer. Back to live coding. So I'm only going to store 100 of them, so we see it moving in this trajectory. And then I press space and it goes off on some other trajectory. Space, and it's doing something else. Well, interesting. It's like a noodle generator. It's quite cool how it travels back and forth on itself. Yeah, something that could be nice is to like debug for myself. I could print up in the corner what these shapes are that I'm on. So I have an idea of which ones are being used for what. Okay, but slowly, ooh, that's nice when it comes really close to the camera. Slowly, I should probably turn this thing into a class so I could have a bunch of these little things. Let's see what this looks like again with spheres instead of ellipses. Or boxes. Boxes are also fun. Ooh, that's a nice one. Wow, that creates a really nice movement. It must be one of these kind of small saw wave-like structures. Something that is always worth adding is orbit control. We always need orbit control. Whoops, what am I doing? Orbit control 5. We lost it. Oh well, we'll find other ones. With orbit control, then we get to like change the perspective of the camera. I think it's best to orbit control before you rotate. Yeah, there we go. So it rotates around that axis. Yeah, I should definitely be debugging. Ooh, that's a nice one too. I should be debugging which one we're getting, because then maybe it's nice to keep track of what some of the nice combos were. And then instead of just being totally random, you can jump and cycle through a few of those. But that's quite a cool one. So what is this? I should just say print algo cell. There we go. So I can see down in the bottom we have, what I don't know is which numbers are being used. It's kind of funny, I didn't give them IDs or anything, but we have the name and the algorithm of which one is being used. Okay. Yeah, it would probably be nice to get the number in there somehow, but not so important. Let's change one more time. And one thing I need to double check is if it's rotating on the right axis. Yeah, I think so. I think it just depended on the wave, if it was really centering around us or if it was out in front of us. I'm building a visualizer of people mail ordering stuff around the world. Okay, but let's play with getting a bunch of these things going, because it's always fun to make these things into a class. Wow, that's a really nice one too. What is that one? Let's turn it on. Whoops. This is, I don't know if I should be going by the shape or the wave. This is the half and half sign combined with the sign, just like the straight sign, combined with ramp with period height. Nice. Let's check out one other one. Yeah, it's super fun playing with these circular buffers. This bit of code right here, just storing a bunch of coordinates, and then once you have too many, saying purge them. That way you get to play with 3D and rotation. Yeah, because it'll be interesting. What would be better is definitely want to make it a class so I could have a couple of these, and then it's a question if these should be tiny, sitting in their own little mini space, or if they should overlap and have different colors and be interacting with each other. Also, just for fun, we have to turn off the background once and see what this thing looks like. Tracing out. You kind of always have to trace and see what that looks like. And maybe once in a while clear the background so we get to start fresh. Or maybe I keep changing it until I like one of the patterns. Like that, for example. And then let it trace and see what it does. But it also plays a huge role in which way you set the orbit control. So maybe I'm going to start it over so it has like 0 perspective manipulated from orbit control and see what it generates. Wow. And I have to remember to take a screenshot every once in a while. One of the main reasons is partly to document it for myself, just to capture what's happening. But just so you know, in P5Live, by default, if you didn't turn it off, it's snapshotting the code every time you take a picture. So when you hit Control S and save a screenshot, you're both getting a PNG of what you see, but you're also getting a JSON file with that particular code behind it. So that can be really nice that you go back and you, like, I'm just keep changing the code, and then if I take enough screenshots, when I really like something, then I could easily grab that code and drag it back into P5Live and have that snapshot. Okay, so those are leaving pretty fun architectural like ruins. Let's turn on the background. Whoops. Turn on the background for a minute, test out a couple of different shapes. This might be interesting, this kind of square wave going up and down. Turn off the background. It's going to be lacking anything from the middle. Let's turn on the background and check a couple other combos. This is a lot of zooming back and forth. I have a feeling the majority of these things, when you trace it, are just going to look like arenas or amphitheaters. Especially if it's on a Y rotation. Let's try another kind. Another one. Ooh, that's an interesting one that really zooms off into space. That's quite cool. This one is the mountain peaks combined with, what is this? A handle? No. Step down combined with a ramp down saw. Let's turn off the background. Better yet, I should make a little toggle so I could turn the background on and off. I'm going to quickly add that. Let's add a BG toggle equals true and put it inside of there. Where is this background? If BG toggle, then we have a background. And then make this a key so I can quickly turn it off. Else if key equals B, we'll use B to toggle it. That equals not itself. Whoops. And that should work. B, B, yep. So now I can hide the code, even though this is all about showing the code. But interesting to just occasionally hide the code, let the thing trace, see if it's a nice output. Okay, I mean, I could keep playing with this, just this thing, forever. But should also go in and explore some other things. So let's check out making this thing a class and have a few of these things running and see what they do. Yeah, that makes a really nice zoom. This is the inverted heart combined, or the mountain peaks combined with the up-down pulse combined with the up-down pulse. So that's also interesting. When you take 3 of those waves and combine them on each other, that's an interesting idea. Maybe I need another function real quick to say what happens when it's all 3 times the exact same thing. So let me not call it rando wave. Let's call it same wave. And then what I'm going to do is I'm going to say let rando cell equal this thing. And then I'll use it 3 times. Tack, tack, tack. So spacebar, maybe instead I should use R for random. And then use S for same. Same, or maybe I call it sync wave. That sounds a bit nicer. All right, so R is my rando. S is synchronizing it, which maybe is not a thing, because then I think you just get diagonal lines. Bummer. Which probably look nice traced out anyways. Everything looks nice traced. Yep, it's like impossible to make a bad image when you trace out the pixels. But, oh no, they're not always a diagonal. Interesting. This is S. What is this one? Scatter down, scatter down, scatter down. Okay, I guess that one's random enough that it doesn't look so similar. But I think the majority of them, yeah, the majority are going to be diagonal lines, just based on what those waves are doing. So maybe that's a new interpretation of what sync means. It means you need 2 different ones. Let's call it like rando cell 2, and then just one of the axes will be some other value. This is already a nice one. What's that like without a background? Interesting. Let it trace a little bit more. Yeah, so now it's synchronized at least for like the X and the Z, but not for the Y, which hopefully every time I press it gives enough of a difference between them. A nice squiggle path. Okay, time to make a class. So I like this 3D. I'm not going to go back. I'm just going to go forward from it. And before I make a class, I always like to clone it in case I screw up, in case I want the simple version without a class. And actually, I'm going to go through and purge whatever isn't necessary for the code. I think I'll turn off the rotating for a minute. I take it back. Yeah, so there's the stuff that's for like everything to use. And then I need to figure out what goes inside the class. I'm going to turn off this stuff, turn off this stuff. This isn't being used anymore. Okay, get rid of this for now. Okay, so it's not too much code. It's like this much here essentially has to go inside of each class. So let's create one of these things. Let's call it class algo. or maybe I call it like algo runner. Algo runner. And we're going to need a constructor. And I'm going to turn off live coding for a minute because I don't want it to try and compile every time I do this stuff. And I know I'm going to need a display to show stuff. And now I can grab the global variables and whatnot. So the C, maybe I'll need an algo cell and I'll need a C to keep track of those coordinates. So I'll say this dot C is that thing. This dot algo cell equals. Oh, and then it's a question actually, instead of these things. Yeah, it's a question if I had just merged those into the class, or if they just return the value instead of actually setting a value. That's another option. Maybe I'd tell these things just to return such a thing. Return such an array. I think that should work like that. I hope. Return this. Let's see if this is possible. It's not happy, I think, just because that's not finished. Yep, okay. So this is going to be a rando waves. Can be a global function. What else am I going to need? This W and H should be global. Everybody should know about them. Maybe the xpos is also global if everything is kind of running in the same path. Let me copy this stuff. I can't set its width or height yet, so that has to be done later. But these can just be variables. And then I have to get rid of the declaration of them. Technically, this isn't going to change, so this can be in the setup. I don't need to constantly be printing that thing out. Xpos is going to update all the time. Maybe I want their speeds to be slightly different, so all of this stuff, I think, from this point on will be nice to be inside the class. So I'm going to say cut and put all that stuff inside a display. So I'm going to have this dot x is xpos from the global. Basically, I'm going to need a ton of this dots. This. Everything is this. This needs to be, again, this algo, this algo, this algo. That's global. This C from this, 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 this. That's a let, so that's okay, and that's okay. Okay, that might already be enough to abstract it. I'll maybe move this xpos just to the very top so it's like getting everything. Can get rid of this there, so there's like no code in the draw. It's now algo runners, and it doesn't really need anything to create it. We just have to invent it. Eventually I probably want to have an x and a y for like, where do I want to put this thing? And so I should create those coordinates. I should say this dot, we're using x, so maybe it's this dot chords has such a vector. And then instead of putting this thing in the center, I will say it is this chords dot x plus whatever that thing's doing. This chords dot y plus whatever that thing's doing. So at the very least, I could put it in the very center. Otherwise, maybe I want to position them somewhere on the page. And maybe it should have a z, why not? And I forget if I can just say equals 0 as a default. I think this is okay to do. I'm not quite sure. Actually, before I do that, let's see if this whole thing is working. Z. And the same thing. Oh, actually, that's the wrong spot to put it. That should be when I do it down here. Okay, this isn't yet getting too crazy looking. Okay, let's see if it works. Done, done, done. I'm going to create just one of them. Let AR for algo runner in the setup. AR is a new algo runner, and I have to give it coordinates. Let's just put it in the center. And then I want to show it to the world. AR.display. Let's hope this works. Boom. Crap. So, what is wrong? X is not defined. Because this... Nope. It just means somewhere I have an X still that I didn't fix. Oh, that's a problem, that I'm using this this X instead of just plain old X, right? Because why is that? All the algorithms are waiting for just the letter X to appear, not this dot X. So I think the way I can fix that is by saying each class has a let X. Yay, there we go. And now it's just a plain X. It's not a this X. That's quite a cool one. And then I'll find out if that's a problem or not when I make two of these things. Let's hope not. Yeah, that's a nice combo. I should turn on the print again so I can debug what these things are. Maybe it's also interesting to not just rotate that axis, but to rotate on the x-axis. Oops, I should turn on live coding again. Yeah, it's always the most interesting using the, not necessarily. The Y is just the clearest for visualizing something. Okay, but let's build a couple of these things and see what happens. So I'm going to turn off live coding actually and say let runners equals an array. And I'm going to say runners.push, a new algo runner. I'll just make a bunch of them in the center. I'll do that in a loop for a few of them. Let's make 5 to begin with. And then I will say for AR, let AR of runners is a nice short way to go through the array. That way I could just throw this in there. Okay, let's see what happens. Yeah, so now there's 5 of these things running around doing their things. What's not clear, actually the spacebar needs to be fixed because these keys are just calling that random thing, which won't work anymore. Now it needs to go through and do that function for each one of them, which is why it probably made sense to put this inside of the class itself, actually. It might have made sense to do that. I think I'm going to quickly change this if I recompile once just to see what a couple of these things look like, actually. Yeah, we definitely also need to put custom fill in there. We have like 6 minutes running out of time. So I'm going to quickly move this class inside of those functions inside the class. Clean it up, get rid of the word function. And don't say return. Instead, it's going to be like it was before. Okay. And that way, I also need to call it up here. This dot, I don't say equals to, it just is. This dot random wave. Why did that not work? equals this to augo cell. What's wrong? Rando waves is not defined. I think it's still sitting at the very top in the setup. Yep. There we go. Okay. Yeah, so it's a question. Maybe we don't need 5 of these things, maybe just 3 of them. But what I need to do is quickly go through and say when I press like the R key, this should do ar.rando waves and set all of them to a new rando wave. And this one should do sync waves. So now if I press R, we get totally new randoms. It's a little hard to tell. If I press sync, it'll be interesting to see like what does sync look like instead. There's another sync. And I think these things need color. So I'm going to give them, maybe I switch to HSB mode now. Actually, first I could just give them random shades of gray. Let's do that. Let's make it in the constructor and say this dot fc equals random 255. And then let's use that inside of their fill. And maybe do the same for a stroke color. SC. Stroke color. Okay, let's see what that looks like. Interesting, at least now we can tell them apart. Give them a new random wave form. Maybe it's interesting to stop playing with blocks in a minute and see what some of these things look like again with either spheres or rings. It was kind of interesting, I trashed it, but it was interesting to see what they look like as just ellipses. Whoops, they need to be 0, 0, 20. Yeah, it's also interesting, maybe I turn off the fill, no fill, so that we just get these rings. Maybe they should be bigger. So that you can see through these different rings. I'll put them on a synchronized wave. It's not really synchronized because it's not, they're not all listening to the same one, they're on their own thing. Maybe they should also have a size assigned to them. Now with much larger rings. Yeah, but we lose some of the 3-dimension when we go to these rings, unless the rings themselves are spinning around, which can of course also be fun to say they are at that spot, and they rotate their Y based on radians, based on frame count plus I times 5, for example. And then it's a bit hard to tell, but maybe if I stop rotating for a minute. There we go. We can see them spinning around on their own little axis. They're going way too fast. So I should slow that down. That is too slow. Divided by 2. There we go. You get some interesting twists happening on some of them. It doesn't really work if they are sitting too far out from each other. I'm going to try the opposite and say no stroke. interesting. It's super slow while it's loading them up, and then they like take off running. And it might be interesting to see what this looks like with lights again, so that we can tell them apart based on where they are out in space. I'm gonna synchronize, try some different wave forms. Maybe it's interesting as well that they shouldn't be a single fixed color, but from the first one to the last one, they could be a shade of gray. Yeah, I think it's always nice to spin this thing around ever so slightly. Maybe not quite as fast, just so that we can take in the depth as it spins around. It could be even slower. Let's try some different waveforms. Yeah, we get some interesting bubble structures, which means we have to try one super big and see what happens when these things cross over each other and do some like z-index fighting. Yeah, too big. And then I'm curious what it's like when they're way smaller and are just like these little dots running out in space. Kind of building these fancy 70s lights. Let's try another random pattern and turn off the background. Yeah, they might be running too fast in space. I'm going to try real quick slowing them down by telling this whole thing that it's all based on to just be slower. And actually they're all using this global X, so I could easily put this thing way up in the draw since the whole world is listening to it. I was going to customize each one, but I guess not. Instead, this will be a global value. So everyone is listening to it. And then that's nice that in the draw, you can live code and speed the things up and tell everyone to go way faster around the board, or can slow it way down, 05. And then we can really see these trails. Yeah, it's quite nice slowing the things down, maybe even more. Then we'll just get these kind of moving shapes. I'll put it on a new random wave, a new random one. They might need a little bit more speed than that. And now that we've slowed it down and it's not so chaotic, I could let there be more of these things. Yeah, and turn off the background for a minute so that we're leaving traces. Getting some interesting silvery colors to appear. Yeah, I'm going to try, whoops, opened up the chalkboard. I'm going to try adding a bunch of these things. Let's have 30 of them. And see how much the computer loves or hates this. It hates it. Let's do 20. That's a little better. And then what I could actually do is, as I go through each one, I could tell them runners I dot FC for the fill color equals map I from 0 to 20, 0 to 255, and actually it's 19. And that way each one has its fixed shade. The very last one will be white, the very first one will be black. And then we can really tell them apart instead of being random. And even if they had a size, last thing, this .s for size was maybe interesting when it was like random 100, maybe from 5 to 100 instead of this fixed value I had down here. All right, this is endless. I'm going to keep playing. Here it is with boxes. I hope you enjoyed checking out P5Live Sessions this week. We'll be back next week, same time, Tuesday evenings, 9 p.m. Central European Time. See you next week.